I forgot to set up my magic pen. All right, so think about the word equation. What is the root of the word equation? What is the root word for the word equation? Anyone? Equal. What was that? Equal. Equal, yeah. So an equation has to have an equal sign in it. If it doesn't have an equal sign, it is not an equation. So that's one big thing. Inequality has to have a sign in it that is not equal. And there's a few of those. And an expression is anything that doesn't have an equation or an equal sign. So for example, I'll make a little chart here. Split the board into 3 parts for expressions, equations, and inequalities. So expressions are things like 3 times 10 to the 12th power. That's an expression, even if it doesn't have variables in it. Things like 2 times x, 3x plus 1, 1.8 times 2 to the power n. X squared plus x over 2x plus x plus 1. Those are all expressions. They have numbers and variables and other symbols, but there's no equal signs, there's no inequalities. Equation, anything with an equal sign. So like 3x equals 18. Usually equations are things we want to try and solve. Can we always solve an equation? Not necessarily. Example, let's see. F equals 9/5 C plus 32. Anybody remember that equation from their past life? What do you think it represents? Temperature, yeah, Fahrenheit and Celsius. So if somebody gives me a Celsius temperature, I can plug it in here, multiply it by 9/5, add 32, that tells me what the Fahrenheit temperature is. Okay. So there's really nothing to solve there until I've given one of the numbers. This one right here, right, you all might have solved equations in some past life math class. I might divide by 3 and figure out that x is 6. Okay, so there's different kinds of equations. Some are solvable, some are not. But anything with an equal sign. Inequality of things without an equal sign. So like g has to be greater than 7. 3x plus 5 is less than or equal to 7. As far as inequality symbols, equal sign, there's only one symbol for equals. Inequality, there's less than, there's greater than, there's less than or equal to, there's greater than or equal to, and then there's not equal to. That's an inequality symbol too. So there's 5 symbols that represent not equal. So it's just getting used to terminology here. And so you have there's part of the worksheet that says, can you categorize each of these things as an expression, an equation, or an inequality? There's a homework problem that's similar, just to follow up on the language there, because that's going to come up as we move along in the course. Not too exciting, just a little definition stuff we got to get used to. All right, more fun. Let's go back to exponents, which we need for scientific notation. Anybody know a word that's usually synonymous with exponent? That's okay, it's Monday. Oh darn, it's not Monday, it's Tuesday. Starts with a P? No. O? Power, there we go. Okay, I was wondering how many letters I was going to have to give. What game show is that? They keep giving letters, you got to guess the phrase. Wheel of Fortune. All right, yeah, let's play Wheel of Fortune. So power is usually synonymous with exponent, but they kind of mean slightly different things. Another word, ooh, anybody want some extra credit? No? All right, forget about it. You guys are so quiet today. Someone say, yeah, I want some extra credit, darn it. Come on, Cole, help me out here.
I do.
Okay, thank you, Jenna. So here's some extra credit for you. Extra credit, due tomorrow, if you want credit for it. Find me another word synonymous with exponent. Okay, so synonymous means the same thing, right? Now, exponent can mean different things. Does anybody know of a definition for exponent besides something like 2 to the 3rd power? An exponent can be a person who speaks loudly about something, right? So I don't want a synonym to that version of exponent, okay? Like proponent would be like an exponent, somebody who speaks loudly about something. So I want a mathematical word that means the same thing as exponent. Okay, so that is your extra credit. Come to me tomorrow with an email or a piece of paper that says this word means the same thing as exponent. Okay. What's it worth? Each homework assignment is worth 10 points, so this will be worth 5 points, half of a homework assignment. Okay. I think that's a pretty decent chunk there. So we talked about exponent last week. There's a couple of different versions. Some people look at exponent and they say, oh, it's the number of times you multiply. But didn't we figure out that's not quite true? What is it really? What does the exponent really tell me to do here? I'm a machine, you have to tell me what to do. What does exponent really mean? Okay, we don't multiply 3 times. We only multiply twice, but what I need you got to tell me what to write down here. How many times do I write the base? Yeah, it tells me how many times to write the base. Then multiply. So 2, 2, 2. I'm actually only multiplying twice. There's only 2 multiplication symbols there. So exponent really means the number of times you write the base, at least for whole numbers. So that's what an exponent really means. For whole number exponents, it turns out there's other kinds of exponents we'll get to today. So that's pretty straightforward, not bad. Let's take 2 cubed, 2 squared, 2 to the first. 2 cubed is 2 times 2, which is 4, times 2, which is 8 on a good day. 2 squared is 2 times 2, or 4. 2 to the first means just write it once. I don't even get to multiply. Oh well. Shit happens. At least I wrote something down. I'm just going to review a pattern I did last week. To get from 4 to 8, you could say I divide by 2. To get from 4 to 2, I also divide by 2. What's the next logical power that I should write down? 2 to the 0. And according to my pattern on the other side, I have to take 2 and divide by 2, which is 1. So just a reminder, most numbers to the power 0, the answer is 1. Okay? So off to the side here, what would 3 to the power 0 be? 1. What would 1/2 to the power 0 be? 1. What would 1,000,000 to the power 0 be? 1. Okay. So it's just a rule based on this pattern with exponents. And again, last week we took this one step farther. 3, 2, 1, 0, next logical number, -1. If I continue the pattern of dividing by 2, then I'm going to get 1 divided by 2, which I could write as a fraction, 1/2. So a negative exponent means flip the base. And we need that to talk about small numbers. For example, 0.1, ooh, messed up my pen. 1, 2, 3, 4, let's go right there. Now I need more zeros. There we go. That's a lot of zeros. It was kind of a pain to write. I can instead write this as a power of 10. To do that, I just have to identify the place value. So I'm going to try to do that. I went 1, 2, 3, 4, 5, 6, 7, 8, 9 places before I put the 1 down. So that should be, in my opinion, 10 to the negative 9th power. All right. So now I'm going to apply rules of exponents to figure that out. What does a negative exponent really mean? Flip it, flip the base. So this black expression is really 1 over 10 to the 9th power. So just think about this for a second. 10 squared equals what? 100, right? A 1 with 2 zeros, 10 squared, 2 zeros. So 10 to the 9th would be a 1 with how many zeros? 9 zeros. So this is really equal to 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, which is what number? So that's 1 billionth. If I wrote it in words. So let's just double check by naming the place values up here. All right, so I need you guys to wake up and play along with me. Ready? Kristen, you got this, right? Okay, no, yes. That was like a, okay. Tenths, hundreds, thousands, 10 thousandths, 100 thousandths, millions, 10 millions, 100 millions, billions. Okay, so it is the right spot. Okay, so I'm just double checking that I did it right. Generally, when I do math, I make mistakes, and any way I can find the double check myself is good. Okay, so it all works out. 2 different ways to write it. If I was going to put this number in scientific notation, I would call it 1 times 10 to the 9th. Because usually we want a number to multiply by the power of 10. Multiplying by 1 is kind of boring, so we could, write it with less ink that way. But this right here is scientific notation. Okay, so negative exponents, something we need to get used to. Some other things we need to get used to are playing around with powers. So we're going to do that with variables and numbers. Consider, for example, 2 to the 2nd power times 2 to the 3rd power. Exponent means how many times to write the base. So this one right here tells me to write down 2 2's. This one right here tells me to write down 3 2's. Altogether, how many 2's have I written down to multiply? 5. So I could rewrite all of that as 2 to the 5th power. So what's the mathematical relationship between this number, and that number right there? What happened to get from the top 2 to the bottom? Addition, yeah. So it turns out there's a shortcut. If you multiply 2 things with the same base, and that's important, if you have the same base, then you get to add the exponents. Small numbers, no big deal, but sometimes we're dealing with pretty big numbers and we don't want to write them all out. For example, suppose we have 10 to the 9th power times 10 to the 12th power. Do you really want to write out all those 10s? It's not a lot, but I got better things to do with my life. So instead, I could say this is 10 to the what power by just applying the rule we just observed above. 21st power? Yeah. So a 1 with 21 zeros. Big number, we probably don't even have a name for it. It's so big. Okay. So that's an important rule of exponents. Sometimes this is stated algebraically. So in an algebra class, you would see this as x to the power n times x to the power m. Do I have the same base? Yeah, it's not a 2, it's an x. It's still the same. So I get to write the base down, and what do I get to do with the exponents? I get to add them up, just like before. So my new exponent is whatever n plus m is. So that's the algebraic version of the rule. So suppose I had x to the 7th power times x to the 8th power. Could I write that with less ink? What would I call it?
X to the 15th.
15th? Yeah, x to the 15th. We add those suckers up. And most of us do that in our head. We don't bother writing 7 plus 8, which is fine. But that could be an intermediate step. Okay, next. Suppose I had 2 to the 5th power divided by 2 to the 2nd power. Couple of ways to think about this. First, just think about what does it mean to be an exponent. To be an exponent, it means tell me how many times to write the base. So I have 1, 2, 3, 4, 5, 2's in the top. In the bottom, I have 1, 2 2's. Now, I love problems like this. Still, I used to love these when I took algebra, because if I have a number divided by itself, what do I get to do? Cancel. Now, keep in mind, what does cancel mean in a situation like this? What cancel means is that you're actually dividing 2 divided by 2. What's 2 divided by 2? 1. What happens when you multiply something by 1? Not much, right? So we say the word cancel. It doesn't mean stuff really vanishes. The machinery that's happening there is really I have 2 goes into 2 once. I'm left with a 1 bonnet. Multiplying by 1 is kind of lame, so really it looks like it disappears. Okay, but it doesn't technically disappear. And I can do that over here too. I can cancel those guys. So cancel means basically you're dividing and you have 1's left behind as multiples. So what we have is 2 to the 5th over 2 to the 2nd is equal to 2 to the 3rd power. So similar to before, there's a relationship between the exponents I started with and the exponent I ended up with. What's the relationship? Subtraction, yeah. So it turns out when you multiply 2 numbers with the same base, you add the powers. If you divide 2 numbers with the same base, you subtract the powers. Okay, so I'm going to write that rule down in terms of x's, just to get you used to a little more algebra. So if we have x to some power n, x to some other power m, same base, the fraction disappears. And then we just subtract those exponents. And that's my new answer. So for example, if x happened to be 10 and I had 10 to the 12th power divided by 10 to the 9th power, the fraction disappears. I just write the base. 12 minus 9 is 3, so this is 10 cubed. Oops. And it kind of makes sense. So how many, there's more 10s in the top, right, than the bottom? How many more 10s are in the top? 3 more. That's what this says. There's 3 more 10s in the top. It's simple. Let's try another one. Suppose we had, color, come on, there you go. 10 to the 6th divided by 10 to the 10th. That will be 10 to what power? Yeah, so here I have a 6 minus a 10. I'm losing more than I had, so I get a negative number. So I'm writing the intermediate step instead of just thinking it. So this is 10 to the negative 4th power. Has anyone ever had an algebra teacher in the past that said, you got to rewrite negative exponents as positive exponents, right? So it's kind of like, I don't know if you guys are, let's see, I got to think of a better example. What's something that used to be popular that's not popular? I was thinking bell bottoms, but that's like way out there for most of you. Walkmans, yeah, there you go. Walkmans used to be popular, they're not popular anymore, although they might be collector's numbers these days. In my opinion, not writing things as negative exponents is a fashion thing. There's no logical argument why that's bad. So that's a perfectly good answer. Some teachers would say, no, you need to write that as 1 over 10 to the 4th. That uses more ink, in my opinion. It's not simpler. So it's kind of a fashion statement. So don't worry about it. Sometimes, if there's more of something in the bottom, you get a negative exponent in the end, and that's okay. All right, next. I think we have one more rule to go over, and we're ready to break into groups and kick butt on that assignment. Sometimes we have an exponent or a power raised to another power. So we need to figure out what the heck that means. So think about order of operations. It says you got to do what's inside the parentheses first. What's inside the parentheses is an exponent. So I'm going to rewrite that as a 2 times a 2 to the 3rd power. Now I know we could call that 4. Let's hold off on that for a minute. Okay. What does this exponent tell me to do? To write the base 3 times, right? Well, my base happens to be this set of parentheses, so I have to write it 3 times. Inside, there happens to be a 2 times 2. You with me? Right? The exponent says, write this sucker 3 times. I just did, and I multiplied. How many 2's do I have written out here? There's 6 of them. So I could say that this sucker to the left on the top is really the same as 2 to the 6th power. Do you see a way to get from the old exponents to the new exponent? Yeah, multiply them together. Okay. Now that's different than the rule we had a couple slides back here, where we had the same base multiplied. Notice the base appears twice there. In this new version, the base only appears once, but the whole thing with parentheses is raised to another power. So that's called a power to a power. So I'm going to write that down on the other side here. So if you have some, oops, that's not a pen. And if you have some base to a power, and that thing is raised to another power, so we call this a power to a power, then the result is you keep the base, but you multiply the powers, whatever those numbers happen to be. So if I had a number like 10 to the 12th power, and then I raise that whole thing to the 3rd power, what power of 10 do I really have here? 10 to the 36th power, yeah. Okay, so those are the 3 rules of exponents. So if we have a repeated base with a multiplication or division, that's addition or subtraction. If we have a single base, power to a power, then it's a multiplication of the powers. Those are shortcut rules. How do we come up with them? By just knowing what it means to be an exponent. It's how many times you write the base. Okay, so if you ever get confused, shit, I forget which rule is which, just say, okay, doesn't matter, because exponent just means write the base this many times. You'll get the right answer doing it the long way. No big deal. But these shortcuts are nice to know. All right, let's take a look at the worksheet. I'm going to do 2 problems on the worksheet, and then you guys are going to compare answers with each other. So take a look at problem number 11, please. 2 times 10 to the 5th times 3 times 10 to the 6th, and they want us to clean that up a little bit. So I'm going to take a screenshot of that. All right, so in math, when we write it on paper, there's 3 different ways to indicate you're multiplying. One way is to put that little times symbol, that cross. Another way is to put a dot. Another way is to put no symbol at all. Yeah? Oh, yeah, they are on the printer. If you could grab the 2 of those, I'd appreciate it. Thank you. So my claim here is thinking about the order of operations for a minute. Order of operations, 1 says do parentheses first, parentheses, 2, do exponents next, 3, do any multiplications or divisions, and those you do left to right, and 4, do any additions or subtractions, and those get done left to right. So here I have parentheses, right? But inside the parentheses is a multiplication. So really I've got a multiplication, and another multiplication. My claim is I don't even need the parentheses here because I can just multiply left to right and be all right. So this is the same thing as 2 times 10 to the 5th times 3 times 10 to the 6th. All right, so this is like what, the second to last page maybe? All right, okay. So my claim is that they're the same. And we can just type this into a computer and double check it. We'll do that in a second anyway. Does it matter what order you multiply things in? 2 times 3 versus 3 times 2? Same thing, right? So not only can I ditch the parentheses, but I can reorder these. I can say, hey, this is the same as 2 times 3 times 10 to the 5th times 10 to the 6th. And then I can multiply in any order I want, right? It's just multiplication. So I could say 2 times 3 is, and 10 to the 5th times 10 to the 6th is 10 to the 11th. Okay. So whenever I multiply two scientific notation numbers, I can reshuffle them so it gives me a new number. Now that new number may or may not be in scientific notation. And I'll show you another example of where it's not. So I'm just going to double check this by whipping out a calculator and seeing if the calculator agrees that this thing up there is the same as 6 times 10 to the 11th. Because a lot of times I say things, and because I say them loud and proud, people believe me. But every once in a while, I'm full of crap. Pretty sure I'm not today. All right, so parentheses, what is it? 2 times 10 to the 5th, close parentheses, times 3 times 10 to the 6th. Am I getting this right? Somebody's objecting, somebody go for it. And there's a 6 with a whole bunch of zeros. I'm off to a good start. Counting the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6 times 10 to the 11th, right? Okay. Now, I think after counting those and almost losing track while moving the mouse, I'm thinking, man, I wish this was in a spreadsheet because I could just say throw commas in there, which is kind of a nice trick. So it agrees with me. Let's take a slightly different example. I would, whatever you like. I would prefer whatever uses less ink, right? So I like the 6 times 10 to the 11th, but if you want to write all those zeros, go for it. I don't think it said use scientific notation, did it? Okay. I didn't, that see is another problem. I think it's a guy thing. I fail to read the directions. Sometimes I just jump in and try and get things done. So usually I have the right answer to the wrong problem. Okay, let's do the next one. 4 times 10 to the 5th times 5 times 10 to the 6th. All right, so you write something down. I'm going to write something down, and we'll see if we agree. So this is number 12 on that worksheet. So I think I could write this as 4 times 5 is 20. 10 to the 5th times 10 to the 6th would be 10 to the 11th like before. That's an okay answer. I think it's right. Is it in scientific notation? No. To be in scientific notation, I would have to rewrite this 20 here as 2 times 10. The 10 to the 11th is hanging out, waiting to do something. How would I rewrite 10 times 10 to the 11th? 10 to the 12th, yeah, because that's really 10 to the first power. Same base means the powers add, the exponents add. So this right here is what we call pseudo-scientific notation. Okay. My pen. Hello, pen. Aw. Ooh, this whole thing went out. Oh, I kicked it. There we go. Give me a sec to reset my technology. Uh-oh, I have an orange light. Oh, it's thinking. There it goes. So the 20 times 10 to the 11th, that's what we call pseudo-scientific notation. It's not true scientific notation. This number down here, 2 times 10 to the 12th, that is true scientific notation. So if it said just multiply and simplify, that's okay. This one down here is better, only because scientific notation is popular. All right, I'm almost ready to shut up. Oh man, I talk too much. All right. All right, I guess I'm not ready to shut up because we got to do this chart right here. So, 10 to the 12th power, is that something really big or really small? It's huge, right? 10 to the negative 10th, really big or really small? Really small, like nanotech. Okay, so we want to try and rank these suckers. So look at this list right here. What do you think is the biggest thing in this list?
Distance from the Earth to the Sun.
Distance Earth to Sun.
Pluto.
Distance Earth to Pluto. Oh. Now, Pluto has an egg-like orbit, more so than the Earth. It's really elliptical. So it could be Pluto gets pretty close at some point, maybe closer to the Earth than the Earth is to the Sun. I don't know. I don't know the answer here. Anybody good at astronomy? What do we do when we don't know something like this? Google. All right. Because actually, I don't remember. Okay, distance. No, that's not distance. The distance to Pluto. Okay. Planet, solar system, what's the 7.5? At its most distance, when the two bodies, what two bodies are we talking about here? From Earth, okay. So it's somewhere between 4.67 and 7.5 billion, according to space.com. All right, so closest 4.67. What about Earth to Sun? Distance to Sun. Oh, spell right. 92 million miles. So the Sun is further than Pluto is as its closest. Yeah, so I was right about the way Pluto orbits. It doesn't have like such a round orbit like we have. It has a really elongated orbit that comes kind of closer. All right, so what's the farthest then? Really? I thought the Sun was farther. 92 million miles, 46 billion. Oh shit, billion. Oh my gosh, I missed that part there. Yeah, all right. Yeah, Pluto's definitely farther even at its closest. All right, how about Mars? Okay, we better check Mars. Distance to Mars. Did anyone already do this? No? Did anybody remember me asking yesterday? You guys start doing this? You did start it? Oh, good. Kinda? All right. Did you? I was just hoping you would look and guess. All right. 54 million miles versus the Sun is 92 million miles. So in order, what's the furthest? Pluto, and then the Sun, and then Mars. Okay. So where am I going? Back here. 10 to the 12th. Is that a billion or a trillion? Trillion. Is Pluto really a trillion miles away? No, it's like at most 100 billion, which would be what? 10 to what power? 100 billion. 10 to the 9th is a billion. 10 to the 11th. It's kind of close to 10 to the 12th if we go to the farthest point Pluto is from Earth. Oh well. Okay, so I would put Pluto here, then next we have Earth, then Mars. I'm gonna leave the middle stuff alone for a minute. Let's jump down to small stuff. What do you think the smallest thing here is? Size of a carbon atom, size of a virus, size of a red blood cell. So red blood cells and viruses, they're made up of molecules, but some molecules are pretty damn big. So water is what? H2O, it's a combination. Carbon must be a big thing. So I'm thinking the smallest thing is probably a carbon atom. But does anybody know what viruses are made up of? They're not bacteria, they're different. Viruses are made up of proteins. What are proteins made up of? Molecules, like DNA, proteins. Yeah, so chances are water molecules probably the smallest thing up here, then a virus, then what? Red blood cell. Okay, so let's double check that. So on the list here, red blood cell is probably going to be 10 to the negative 6. So let's look that up. Size of red blood cell in millimeters, sure, why not? It's calling it 150 micrometers. Remember we did that chart the other day with micros and nanos and all that? Or 0.15 millimeters. If we measured in meters, how many millimeters in a meter? Anybody know what milli stands for? 1,000. So that would take these 2 decimal places and move them over 3 more decimal places, which is like 10 to the negative 2 and 3 would be 5 on a good day. Yeah, 2 to the negative 5. So we're kind of close to 10 to the negative 6. So we're in the ballpark, right? So that's kind of what I'm checking. All right, I'm shutting up now. Your turn to work on this. Check with a neighbor. Start filling stuff out. If you finish it today, cool. Otherwise, I want this tomorrow. And your other homework is to get the prep for 1.4 started tonight, because we're going to work on 1.4 tomorrow. Daisy, Jose, if you have any questions, let me know. We're trying to get lesson 1.3 done.